So, no jokes. No ghost jokes.
Ghost joke.
Okay, anyway, the way you do this, you just factor it as if this were 2x squared minus 3x plus 1. Well, a lot of you guys have difficulty with that, but we're going to pretend that you don't. So this factors to 2x plus 1 and x minus 1. So this thing would factor to 2 sine theta plus 2 sine theta minus 1 and sine theta minus 1. Get that? And then you just set that equal to 0 and you solve your 2 halves of your equation. And so this gives you 2 sine theta minus 1 equals 0, which translates to sine of theta. My Moby is 1/2, which means that theta equals 2 possible things between 0 and 2 pi. Who knows what those 2 things are?
It could be 90.
No.
It can be 30 degrees or 150.
Thank you. 30 degrees or 150. AKA pi over 6 and 5 pi over 6. Thank you. 3.
How do you do that?
Because those are the 2 places where between 0 and 2 pi where sine is equal to 1/2. You look on your units. Okay. What? Then you'd have to solve it with a calculator. Yeah, if you don't get a number that is on the unit circle, then you'd have to solve it with a calculator. Okay?
But everything is going to be on the
So I'd say, yeah, but on a non-calculator part, that's a good question. You might get something like sine of theta equals 0.3, just like we did that last problem, right? So you would take the inverse sine, of 0.3, and you would get out whatever that angle is, right? And so that would give you an angle over here, a positive one, and then you'd have to take that angle and subtract it from pi radians, and you get the second angle. So if you have, inverse sine button on your calculator. Oh, you couldn't. You could. Okay? And then I'm not done yet. Yes, you're gonna have a calculator part on Monday, and Tuesday, sorry, and a non-calculator part on Monday. Sine of theta equals 1. So theta equals, there's only one place where between 0 and 2 pi, where sine of theta equals 1. What's that? Pi over 2. And so this has 3 answers. All right? So with this one, oh look, we get to use degrees this time. Okay? So with this one, first you want to do what you normally do with a factoring problem, is bring everything over to one side. 2 sine squared theta plus 3, that should be negative, right? Negative plus 3 cosine theta. You know what I'm going to do instead? I'm going to bring everything onto the right side. So I'm going to go 2 sine squared theta minus 3 cosine theta plus 3 equals 0. And minus 3, thank you. But this looks kind of like a factoring problem, but I can't factor things because this is in terms of sine and this is in terms of cosine. But there is a way to change things that are in terms of sine squared into things that are in terms of cosine squared. What would that be? 1, right, sine squared is 1 minus cosine. So I'm going to write this as 2 times 1 minus cosine squared theta, which is sine squared theta, minus 3 cosine theta minus 3. So maybe I was mistaken. Maybe I shouldn't have brought this onto the left side, but that's okay. Equals 0. Now I'm going to distribute, and I get 2 minus cos squared theta, 2 cos squared theta, minus 3 cos theta. You know, it's really hard up here on stage without making mistakes, you know. You get your screen fright up here.
We have audio
Alright.
right.
What?
We have microphones right.
Microphones, yeah? Okay. So anyway, I'm not done yet. So I'm going to take a picture of it and move it to a new and exciting place.
Woo!
Okay? So I'm not done yet, and I need more room. So continuing this problem, now what I probably want to do is get the cosine squares in front. I'm going to multiply everything because I don't like all those negative signs because it makes me nervous. So I'm going to change all those. Oh, divide. Okay, thanks, Kate. So 2 and negative 3. Oh, and you too, Davis. Thank you. That makes negative 1 minus 2 cos squared theta minus 3 cos theta minus 3 equals 0. And then probably what I want to do just to make my fact. What did I do? I'm sorry. I'm asleep still. All right. There we go. That's right. Right? 2 minus 3 makes negative 1. Now I'm going to multiply everything by negative 1. And what that does, that turns this into a positive. So I'm going to rewrite this as positive 2 cos squared theta plus 3 cos theta. I'm going to stick this positive 1 on the end here. Positive 1 equals 0. Tell me if I made any mistakes. Yeah. Am I okay there, Kate and Davis? Looks good. Now finally I could try to factor that. Okay? Oh, yeah, that factors to 2 cosine theta plus 1 times cosine theta plus 1, which gives me cosine theta equals negative 1/2, or cosine theta equals negative 1. And in this case, we're looking for thetas between 0 and 360 degrees. Degrees, yay. So if you remember, on your unit circle, cosine is negative 1/2 when this angle is 60 degrees.
No.
The reference angle, yes?
Oh, yeah.
Yes, I'm right on that. Okay? So when that angle is 60 degrees, that makes this angle what? What's that angle to there?
120.
120. Yeah, except we're not talking in pi thirds. 2 pi over 3, yes, but we're talking in degrees this time. And then to here, it's how many degrees from here to here? 240 degrees. Okay? And where is cosine theta equal to negative 1? Over here. At 180 degrees. Okay? So those are all my different answers for that. Yeah? X is negative 1 at 180. You got that one? Are we good? Okay, 8 minutes so far. How's that 180 degrees?
Oh, 180.
80.
My bad.
Okay,
8 minutes.
3 more. Let's do this one. So, oh, this looks very similar. That's because it's the same problem. That would be that. Okay, so yeah, you've been doing this long enough and done the same problem many times. Okay, so with this one, anyone have any guesses as to what I might want to do with this one? Yeah, I will want to do that eventually, but that I have no way really to solve something that is a 2 theta and a regular theta. So what I want to do is change this, and there's a way you could rewrite cosine of 2 theta in terms of theta. Is anyone familiar with the cheat sheet I gave you the other day?
Cosine of theta plus theta.
Do you remember this one? 2 cosine squared theta minus 1 is equal to the cosine of 2 theta.
Yeah.
Remember that?
No.
Good? Yeah, that's one of those double angle formulas on your cheat sheet. Okay? And then minus, I'm going to subtract the 5 cosine theta here. Minus 5 cosine theta plus 3. And now I'm going to combine like terms. Let me double check to make sure I'm doing this right. Because I do these problems, believe it or not. Okay? And, uh-oh. Did I do that one?
You got the equation right.
Yeah, I did it
So
right.
try to just do
Okay,
cosine squared.
so again, I'm gonna I'm gonna rewrite this as 2 cosine squared theta. This is equal to 0 over here. That's a theta, a small theta. Minus 5 cosine theta, and minus 1 and plus 3 makes plus 2 equals 0. And then I have to try to factor this, okay? And it's like 2x squared minus 5x, so I know that there has to be a 2 cosine theta here. And I know that there has to be a cosine theta here. And I know that, what goes here? Anyone know? Negative 2. Because this has to be negative 5, right? So negative 2 times this will give you negative 5. And negative 1, or negative 4. And negative 1 times this will give you negative. So that makes my negative 1 and negative. Makes that, right?
Yeah.
And so now I draw my little squiggly line again. And I get that cosine theta equals positive 1/2 this time. Cosine theta equals positive 1/2. And here I get cosine theta equals 2. Okay? So this one, this gives me that theta equals pi over 3 and in the first quadrant, and then again in the fourth quadrant at 5 pi over 3. Okay, those are the 2 places where cosine is 1/2. And cosine of theta equals 2 where?
Nowhere.
Nowhere. Okay?
On the plus.
Yeah, because remember that cosine and sine can never be bigger than 1 or less than negative 1. Okay, so this part of it has no solution. Because cosine can't be bigger than 1 or less than negative. And that's how you do that one. Moving on. 2 more. 2 more, and then we'll be done. So, this one here, cosine squared plus sine. So what do you think I want to do with this one first?
Convert the sine or convert the sine theta to a cosine theta.
What can I turn cosine squared into?
1 minus sine squared.
Very nice. Okay. So I'm going to turn that into 1 minus sine squared over here. So I get 1 minus sine squared theta plus sine theta. I'm going to bring the 2 onto this side. Minus 2 equals 0. I think what I like, well, first I'll combine my like terms. So I have minus sine squared theta plus sine theta minus 1 equals 0. And then, because I don't like to factor things that have negatives in front of them, I'm going to multiply this by negative 1. And when I do that, I have sine squared theta minus sine of theta plus 1 equals 0. And then you try to factor this. But what happens? Doesn't work out. Because there's nothing that will multiply to 1 and add to negative 1. And it turns out, like, if the coefficient of this is A, and the coefficient of this is B, and the coefficient of this is C, then B squared minus 4AC, remember this from the quadratic formula? That's a thing inside the squared roots. That's called the discriminant, the determinant, discriminant? I don't remember. One of those things. Determinant, yeah. It's either discriminant, so B squared minus 4AC is called the determinant. And since B squared is that would be negative 1 squared. So that's 1 minus 4 times 1, which is a coefficient of the sine squared term, times 1. You see that I get a negative number onto the underneath? No, B squared. Yeah, but when I square it becomes positive 1. Okay? Minus 4 times A, which is 1, times C, which is 1. This gives me a negative square root of 3, And so for this one, there's no solution because you have imaginary roots. See? Because it doesn't factor, because the determinant is negative. All right? And the very last one we're going to do right now. And I bet you're excited about that. Okay? So, with this one, you kind of got to be clever. Anyone want to try to be clever? No? Yeah, kind of. So there, I can't turn sine into cosine. I can't turn sine into cosine into sine. But what I can do is multiply through by 2. And the reason that I want to do that, or negative 2, let's multiply through by 2. I get 2 sine theta. Oh, I'm having trouble. 2 sine theta cosine theta equals
Sine of 2 beta.
Ah, very good, Reed. Okay, so what Reed recognized, he said, oh, there's a chair in the way. Good thing we didn't see that on the video. All right, so this thing here is equal to sine of 2 theta. If there's one double angle formula I really think you should memorize, I think it's sine of 2 theta, because that one comes up a lot in calculus. I remember because I taught that. And it does show up, and you're kind of expected to know that. So I would memorize that one. The cosine double angles, they don't come up as much, and I'm not going to make you memorize those, but this one you should know, because it does come out a lot. So 2 sine cosine theta is the sine of 2 theta. So then I want to know where is sine of something, we'll call it u, equal to negative 1. Where is sine equal to negative 1?
3 pi.
Right over here, right? At 3 pi over 2. But that's 2 theta, right? Plus, every time I go around the circle, plus 2 pi k. Yes? With me there?
Yeah.
But I want to find theta, so what do I have to do?
Divided by 2.
Divide everything by 2. So this gets divided by 2, so I get 3 pi over 4. And I have to divide this by 2, which turns that into a what? A pi k. Okay? So these are all the places forever and ever where theta is equal, where this equation works. So 3 pi over 4 plus pi k. So if I want to list some of them, 3 pi over 4, then 4 pi over 4 more, which is 7 pi over 4, and then 4 pi over more, because that's pi k, 11 pi over 4, and so on. And if you graph this function, you would get, I think we should graph it. Should we graph it?
No.
We got time. I'll do it for a second. Just to show you what I did graphically, I graphed the curve y equals sine of x cosine x, and I graphed the curve y equals negative 0.5. And the first place that they intersect is 135 degrees, which corresponds to my 3 pi over 4, right? Because pi over 4 is 45 degrees, so 3 pi over 4 would be 135 degrees. So there's my first spot. Then the next spot would be down here, which would be 7 pi over 4, and the next spot would be 11 pi over 4, and so on. So that's another way you could look at that. Okay? All right, the end of my cutting edge video. Bye.